Welcome to my class. In today's class, we'll be talking about the periodic table. What is the periodic table? The periodic table is the arrangement of elements in order of increasing atomic number into rows, termed the period, and column, termed the group. As you can see from the periodic table being displayed, the group is actually those vertical columns, while the period is the horizontal row. Let's talk about the history of the periodic table. The history of the periodic table is a fascinating journey that spans centuries and involves contribution from many scientists. In ancient times, the concept of element began with the classical elements, the earth, water, air, and fire, proposed by the Greek philosophers like the Empedocles and Aristotle. In the 18th century, chemists began isolating and identifying individual elements, and some of the scientists that contributed towards the development of the periodic table include Antonio Lavoisier. He presented a list of simple substances which are divided into 4 groups: oxygen, nitrogen, heat, and light. He actually discovered oxygen and nitrogen. Sulfur, phosphorus, which form acidic oxide, metals such as copper, tin, zinc, and lead, then simple ethyl salt. In the 1980s, chemists such as Johann and John Newman attempted to classify elements based on their properties. Johann actually proposed the triad, while Newman proposed the law of octaves. These were attempts to arrange elements in a periodic manner. Dobereiner noticed that the relative atomic mass of strontium was approximately the mean of the relative atomic mass of calcium and barium. He later found out that 3 elements, the triad, whose properties are similar. Actually, he grouped elements into 3 which are actually similar or possess similar properties. This he called the law of triad. The law of triad states that when elements are arranged in order of increasing atomic masses, group of 3 elements, the triads having similar chemical properties, are obtained. As you can see from the table above, the elements are actually in group of 3. Let's talk about the Newman law of octaves. It actually says that when elements are arranged in order of increasing atomic masses, every 8th element has properties similar to that of the first element. Disch-Courtois arranged elements in order of their relative atomic mass in a spiral manner or cylindrical manner divided into vertical stripes. Julius Lothar Meyer, a German scientist, and Dmitry Mendeleev, a Russian scientist, independently proposed their versions of the periodic table. Mendeleev's periodic table was particularly influential because he arranged elements by their increasing atomic masses and observed periodic trend in their properties. Mendeleev noticed that similar properties kept reoccurring at a regular interval. Hence, he arranged them in horizontal rows called period, and the vertical column is actually called group. Let's talk about the Mendeleev law of periodic table, which states that the properties of elements vary periodically with their atomic masses or weight. There are some drawbacks or limitations to Mendeleev's periodic table. He placed iodine with relative atomic mass 126.90 after tellurium, which actually has a higher atomic mass. Secondly, there was no place for the noble gases, which were actually later discovered after Mendeleev's periodic table. It was actually Henry that showed that elements are arranged in a periodic pattern according to their atomic number. This actually gave birth to the modern periodic table. Let's talk about the modern periodic law. It states that the properties of elements are actually in a periodic function of their atomic number. In other words, the properties of an element varies with their atomic number in a periodic manner. Let's take a look at the periodic table being displayed on the screen. This is a mini periodic table harboring only 1 to 20 elements. Elements in group 1, apart from hydrogen, are regarded as the alkali metal. Group 2, alkali earth metal. Group 7, halogen. And group 8, the noble gases. Now, modern form of grouping these elements, where we can group them from 1 to 18 will be discussed in a later video, as well as details of their various properties. Let's just talk about few of their properties. Elements in group 1, as you can see, have one valence electron in their atomos shell. This electron they can easily give out. These make them actually very reactive metals. They can easily combine with elements in group 7 that actually have 7 electrons in their atomos shell. Thereby, they can accept 1 electron. In summary, elements in the periodic table are divided into metals, non-metals, and metalloid. Group 1 and 2 and some in 3 are regarded as metals, 4 and 5 metalloid, and 6 and 7 are usually non-metal. Metals are good conductor of electricity, while non-metals usually do not conduct electricity. The periodicity, or how the properties of elements in the periodic table, such as how atomic or ionic radar varies, ionization energy, electroaffinity, and electronegativity, and as well as other properties will be discussed in details in subsequent video. Thanks for watching.